Okay, so we are going to, hello, good to see you. Talk about this trigonometry. So we use trigonometry in Algebra 2. We use it in pre-calc. You're going to see it in calculus. So today's lesson will appear again and again. We are only focusing on sine, cosine, and tangent today. You can ignore this over here because that's for my other class, but I just didn't want to erase it every period. So here we go. What these words mean, a sine, cosine, and tangent. They are words that compare the sides of a triangle. Of course, you guys know that the hypotenuse is always the hypotenuse. Right? Always across from the 90-degree angle. Okay, so there's that. So, sine. The ratio, which means it's a fraction, of the leg opposite to the angle. So I'm going to have to look and say, like, this is angle A. This one's called angle B. And I really only care about A and B. I obviously know that angle C is 90 degrees. So angle A and angle B. So the ratio means I'm going to create a fraction of the leg opposite to the hypotenuse. So if I were doing, like, let's practice. The sine, this means the sine, the relationship between two numbers of angle A. That's what this means, sine A. Okay, sine means opposite over hypotenuse. Look here, I wrote it, and you probably will see we're going to write this a lot on our papers today. S for sine, opposite over hypotenuse. So the sine of angle A is going to be here. Here's angle A. I want to know what is opposite angle A. Lowercase a. It's this long. I don't know how long. I'll say lowercase a. Opposite over the hypotenuse of this triangle. The hypotenuse of this triangle is lowercase c. That's how long the side is. It's c long. So your ratio, your fraction is A over C. Okay? Sine of angle B. Here's angle B. Sine means opposite. Now, my opposite, look, this is the angle opposite. I'm sorry, this is the side opposite. Lowercase b over hypotenuse. Lowercase b over lowercase c. So sine, opposite side, whatever angle I'm looking at, the side opposite it, divided by the hypotenuse. Cosine. Cosine is another vocabulary word, and it compares adjacent. Now, remember, adjacent means next to. So it's the side that's next to the angle. Cosine of A. So here's angle A, right? Adjacent, right next to it. You don't say the hypotenuse is adjacent because the hypotenuse has its own classification. It's always the hypotenuse. So if I'm looking at angle A and I say, what's adjacent? It's going to be this side B right here. Adjacent over hypotenuse. My hypotenuse is C. Then let's do cosine of B. Here's angle B, capital B. Adjacent. Well, yeah, the hypotenuse is adjacent, but the hypotenuse has its own description. So I do not say that the hypotenuse is adjacent. This is the adjacent side. Lowercase a over lowercase c. Cosine, adjacent over hypotenuse, right here. C, adjacent over hypotenuse. Tangent. third term in trigonometry. The ratio of the side that's opposite, the leg that's opposite, and then the leg that's adjacent. I'm going to do tangent of A. Here's A, capital A. Tangent of A. Opposite is lowercase a over adjacent, lowercase b. Opposite over adjacent. Lowercase a over lowercase b. Lowercase a over lowercase b. Yep.
How would it be like lowercase b over big C? This isn't like the big C.
This is the angle though. Capital C is the angle 90 degrees. Capital B is the angle here. Capital A is this angle up here.
So we don't count the right angle.
You don't count the right angle ever because the right angle is, we know how big it is, it's 90. Tangent of angle B. Here's angle B. Tangent, opposite, opposite over adjacent. B over A. Opposite is lowercase b. Adjacent is lowercase a. Now it's always really hard to do when I don't know how long the side is. So we're actually going to do this with actual real numbers because that's truly beneficial. Okay, I'm scrolling down. Yay, I have real numbers. And I have a typo. Let's do this. Okay. Can you guys adjust this so that this says sine of n, cosine of angle n, tangent of angle n? So it's a typo on the paper. Please put n's here for these. Sine. We know sine. It's opposite over hypotenuse. So, sine, opposite over hypotenuse. That's a way to remember it. So, S-O-H, so. Cosine is adjacent leg over the hypotenuse. A and H. S, sine has O and H, so cosine is adjacent and the hypotenuse. So I'm going to use ka, C-A-H. So ka, tangent, opposite side over adjacent side. Toa, tangent, opposite over adjacent. SOHCAHTOA. SOHCAHTOA is the acronym that we teach students to help them remember which one is sine, which one's cosine, what's tangent. Okay, here we go. Let's practice lots. I have a triangle, LMN, and it is not complete. 6, how do I find the missing side? What math method do I use?
Pythagorean theorem.
Pythagorean theorem. So it's like 6 squared plus I don't know squared equals hypotenuse squared, right? Go ahead and do it. If you guys need calculators, come grab. 6 squared is 36 plus x squared equals 100. Subtract 36 both sides. X equals 8. 6, 8, 10. 6, 8, 10 is a Pythagorean triple. There's like 3, 4, 5. We learned about this last week. 6, 8, 10. All right. Find ML. We did. It's 8. Great. Sine of angle N. Sine of angle N. Okay, the triangle's upside down. It's fine. Angle N, sine, opposite over hypotenuse. Opposite is 8, hypotenuse is 10. 8 over 10. Reduce, reduce, reduce. Always reduce. 4/5. Okay. Cosine of n. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So go to angle n, and I'm going to write down the adjacent. Look, the adjacent is not the hypotenuse. It's the leg that's next to angle n. 6 over the hypotenuse of 10. 3/5. Tangent of angle n. Opposite over adjacent. Opposite over adjacent. Opposite side is 8. Adjacent is 6. 8 over 6. 4 over 3. And I'm going super slow, so you guys, right? No one should be behind, because I'm like a snail right now. All right, we're gonna practice. The next page has all the practicing. All the practicing. Check this out. SOHCAHTOA. You need to have this memorized. You need to know that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and that tangent is opposite over adjacent. Can you write SOHCAHTOA on your paper, please? Here we go. 5, 12, 13. That's a Pythagorean triple because the numbers work out perfectly. So we're going to do the sine of the two angles and A and C. Sine of A. Opposite is 5. Hypotenuse is 13. Sine of C. Opposite is 12. Hypotenuse is 13. So angle C, opposite it is 12. 12 over 13. Cosine of angle A. Now, adjacent over hypotenuse. Angle A. Adjacent leg. 12 over 13. All right. Cosine of C. Angle C. Adjacent over hypotenuse. Adjacent is 5. Hypotenuse is 13. So we did sine, we did cosine. Let's do tangents. Opposite over adjacent of angle A. Opposite 5 over 12. 5 over 12. Tangent of angle C. Here's angle C. Opposite over adjacent. Opposite is 12, adjacent is 5. 12 over 5. All right. Questions on number 1. Okay. On number 2, there's a side missing. The hypotenuse is missing. 9 squared plus 12 squared equals C squared. Right? Go ahead and do it. I can't do everything.
15.
15, because it was 225. Okay, practicing. Ready? Ready? Sine, W, opposite over hypotenuse. 12 over 15. Always reduce 4/5. Yeah. Sine of x. Opposite of our hypotenuse, 9 over 15. 3/5. Okay, you guys start helping me. I'm talking too much. Cosine of angle W is what?
3/5.
9 over 15 first. Yep, 3/5. Cosine of x. Adjacent over hypotenuse.
Twelve over 15?
12 over 15 is correct. 4/5. Tangent now. Tangent of angle W, someone?
4 over 3.
So you had 12 over 9. That, you're right, is 4/3. And tangent of angle X.
9 over 12?
9 over 12. Correct. 3/4. Very good. Okay, 3. I really would like you to just do 3 without my, 16 something 34. Pythagorean theorem. 16 squared plus I don't know squared equals 34 squared. Go ahead. What's the missing side?
$30.
30. Okay, I'm going to pause the video. I'm going to give you 6 trig ratios to write. So maybe like 2 minutes or so. Okay. Tell me. Sine of angle L.
16 over 34.
So sine means opposite over hypotenuse. Angle L. Opposite over hypotenuse. Opposite of angle L is 30.
Oh, 30 over 34.
Yeah. Reduces to 15/17. Divide by 2. 15/17. Okay. Somebody else, sine of angle M. 16 over 34, I like that, yeah. Is 8/17. Cosine of angle L. Adjacent over hypotenuse. Someone. 16 over 34. Then you guys are done helping, thank you. 8/17. Cosine of M. Someone on Zoom.
15/17.
30/34. Reduces to, yes, 15/17. Very good. Tangent, opposite over adjacent. Angle L.
30/30. Oh wait, 34.
I think it's 30 I like on top
Over 16.
over 16. 15/8. Okay. Last one, yay, tangent of M.
16/30.
And that is 8/15.
8/15.
Yeah. Phew, great. This last section we're going to need a calculator for. Because in your calculator, there's a button, sine, S-I-N, cosine, C-O-S, tangent, T-A-N. And what you're going to do, your calculator, you might have to enter the number first, and then press the sine button or the cosine button or the tangent button. Or maybe you press the button first and then enter the number. But these degree measurements have a decimal value. The angles, when I find like the sine of an angle, it has a decimal value. And that's what we're going to look at down here. I'm going to round to 2 decimal places, the 100th place, right? Okay. In your calculator, press the sine button and then press 55 and press enter. We're rounding, so this is going to be 0.82. Did you all get that on your calculator? So you know how to do it. Play around, maybe the number goes first and then you press sine, or maybe you press sine and then 55, enter. Cosine 110. 110 degrees. The cosine of 110 degrees is a negative number. Totally fine. Negative 34 hundredths. Tangent of 12. Points 21. Keep going, finish them off. Sine of 146. 146 degrees. Okay. Cosine 89. Tangent 115. Okay. I'm going to stop the recording.